Okay, so now I'm gonna go through the Unit 4 practice test. So starting with number 1, we are looking at a grad cylinder and we have to figure out what place we wanna read it to. The rule here is you figure out whatever your measurement tool goes to. In our case, each of these ticks represents a 1. So it measures to the 1's place. We always wanna estimate 1 place further, so we're gonna estimate to the 10th. So you guys should have gotten A. Same idea for this thermometer. In our case, it is going up by 1s, so we're gonna measure to the 10th place. You guys should have gotten B. How many decimal places should be in the answer if 2.214 is added to 6.3? Well, for addition and subtraction, it is limited by the number of places after the decimal. So the least number here is just 1. So you should only have 1 after the decimal place. The measurement of 0.41006 grams rounded to 3 significant figures is expressed as, so the way I would approach this problem is I start from the left most significant figure. In our case, that is 4, and I count 1, 2, 3 places. This 0 is where I'm rounding to, so I look to the right, it's another 0, so it does not go up, we are rounding down, and so you should get B, 0.410. The following weighings were made during a laboratory exercise, and so in this case, it's another addition. And so we are limiting to 2 places after the decimal because that's the least. And so you guys should have gotten B. A student calculates the density of an unknown solid. The mass is 10.04 and the volume is 8.21 cubic centimeters. How many sig figs should appear? If you take 10.04 and divide it by 8.21, you should have gotten 1.22289, whatever. In our case, you wouldn't even have to calculate this to figure it out. If you look at for a multiplication and division, now it's limited by the least number of overall sig figs. Here we have 4, here we have 3, and so we can only have 3 sig figs in our final answer. Expressed in proper scientific notation, 0.00213 is which of the following? Well, if we move the decimal 1, 2, 3 places, we now get a coefficient between 1 and 10 of 2.13, and it's times 10 to the negative 3rd, which is C. For number 8, how I would approach this problem is you have to convert both numbers out of scientific notation, add them together, and then convert them back. So 1.2 times 10 to the second is 120. The next one is 34. If you add them together, you get 154. And converting that back into scientific notation and considering sig figs, you get A. Number 9, you don't have to know what KSP is. What the problem is asking for is which is the most soluble. Well, if the most soluble has the higher number, we're just looking for the highest number out of A through D. When you have negative exponents, the smaller the negative exponent, the bigger the number. So you should have gotten D. How many kilojoules are equivalent to 10 joules? So in our case, if we think about the staircase, we're comparing kilojoules to joules. The one higher up on the staircase is kilojoules, which gets a 1. And then if you were to count the stairs in between, back to the base unit, you would get 3. So the conversion is 1 kilojoule to 10 to the 3rd joules. And so if we start with 10 joules, we're going to multiply that by the conversion factor of 10 to the 3rd joules so that our unit of joules will cancel out and we will be left in units of kilojoules. You should have gotten B as your answer. For number 11, we're changing 1,500,000 microliters to deciliters. So here we're comparing microliter and deciliter. We look at the staircase again. Deciliters, the bigger unit, it's towards the top of the staircase. And then microliters is 5 stairs away, so 10 to the 5th difference. And so if we set this up as our number of microliters, here we are going to put 10 to the 5th microliters on bottom, again, getting those units to cancel out, and 1 deciliter. And so you guys should have gotten B as your answer. Any questions thus far? Yeah, go ahead.
Would it be only 2 spots because it's decimal, not decimal?
No, so if you look at the staircase here, this is deci,
Right.
this is micro.
Oh, it was micro. I thought it was mil.
Yes.
We're gonna have to memorize this, right?
Nope, this will be up on the board for you.
Oh, sweet.
I don't care. I don't want you to have to deal with memorizing this. I just want you to know how to use it. Okay. Okay. Any other questions? Okay. Which 2 prefixes have a conversion factor of 10 between them? So keeping in mind that each stair you go changes the factor of 10, you want to find something that's only 1 stair away. Well, that is option C, milli and centi. And number 13, to convert 1.25 milligrams to grams, which of the following should you perform? If we look at milligrams and grams, grams is the bigger unit, milligrams is 3 stairs away, so 10 to the 3rd power, which is the same as 1,000. And so if we were to set up this conversion factor, C would be the right way to do it. Number 14. So here's kind of a 2-parter. So it's talking about a student measuring both mass and volume. And so they're going to calculate the density of aluminum. And so you had to look up an accepted value of aluminum and calculate percent error. So if you figured out the density, you should have gotten that 2.8 grams per cubic centimeters. This is the experimental value. And so now we're going to have to use our accepted value, which if you looked it up, that is 2.7 grams per centimeters cubed. And now we're going to use the percent error equation. This will also be given to you on the test, but what it is percent error is equal to experimental value minus your accepted value divided by accepted value, all times 100. And so don't forget, it's important to point out that these vertical lines, that represents absolute value. So if you get a -%, just turn it into positive. That is still the correct answer. And so if I plug this in, I get 2.8 minus 2.7 divided by 2.7 times 100. That gives us D as our answer here. Okay, solve for T using this equation. Well, if we think about Y over our imaginary 1, and same with BWT, all we do is, for solving for T, is we take B and W. If we cross it over to the opposite side and the opposite part of the fraction, you'll end up with T is equal to Y over BW, or C. Solving for J. So the biggest thing here is we do not like when the variable we want is in the denominator, so I'm going to cross that out first. Well, here, we then will take Q, cross it to the other side, other part of the fraction. TP we don't want, we're crossing that to the other side, other part. And I know this seems like a hot mess, but what you get as your answer is A. Solving for H using this formula. So we want to keep H. We're going to cross Y from the denominator to the numerator on the opposite side. Q from the numerator to the denominator. You should get B. Any questions on those? So I'm using the method of the Edpuzzle I had you guys watch when you were online. If you do it a different way, that is totally fine. Just make sure we're getting the right answers here. Yes, it is C. My bad. Word. Okay. All right, so a lot of people shuddered when they saw a huge paragraph. If anything, this is more practice for the ACT. This is what they're gonna throw at you. What should you do for ACT? Go to the questions first, right? So we're gonna hop right to this question, and it's asking you to calculate the volume of a diamond that has a mass of 2 grams. So if we have volume, mass, the other missing part is density. So if density is equal to mass over volume, we are given our mass of 2 grams. We need to figure out our volume. And so the only thing we need to pull out of this paragraph is diamond's density. If you look at the only sentence with numbers, it's right there at the end. So you didn't even have to read that whole paragraph. If you plug it in, or if you solve for volume, we're moving volume to the numerator, because remember, this is over 1. Density will get moved to the denominator over here. Volume is equal to mass over density, which is equal to 2.00 grams over 3.51 grams per centimeters cubed. What do you guys get for a volume? Awesome. 570, right? Yeah, okay. Centimeters cubed. Any questions on that one? All right, more density stuff. So first part is asking you to calculate the density and show your work. So in our case, we need to first figure out what we have. So density, we don't know. Mass is given as 10.23. But how do we figure out volume from this problem? Exactly. We did the method water displacement, so you have to take the volume of the water in sample, subtract the volume of just water initially, and so your volume of your sample is actually 1.5 mils. And so if you calculate your density, which would be 10.23 divided by 1.5 mils, your density is equal to 6.8 grams per milliliter. If the accepted value is 6.93 grams per mil, calculate percent error. So we're doing percent error again here. So we would have 6.8 minus 6.93 divided by 6.93 times 100. What do you guys get for percent error here? Is that 1 point? A lot of different answers. Okay, 6.8 minus 6.93 divided by 6.93 times 100. I got 1.9%. Now, C, this was kind of more of a concept question. It's just asking what kind of error could possibly be introduced if we measure the volume first. So we need to think of an in-lab application of this question. How did we measure volume here? We put it in water. We did water displacement. So where do you think some issues could rise if you put your sample in water before you weigh it? Exactly. So there's a possible introduction of error from water still being on the sample. That would give a false reading of mass. Okay, now we're gonna start doing some rearrangement. I'm just going to preface this with the way that I do this may not be the way you have done this. That's the cool part and scary part about math is there's multiple different ways to do it. Doesn't matter as long as you get the right answer. And so the key here is we're solving for thickness or height. So overall, we want to end up with h is equal to something. The key to combining equations is finding a variable they both have. In our case, that's volume. And so we already have one solved for volume. We have to solve the other for volume. And so if we put volume in the numerator, density in the denominator, we get volume is equal to mass over density. Well now, so this would be step one, which is rearrange for volume. And now we're gonna set both equations equal to each other. So we would have length times width times height is equal to mass over density. Now we're going to solve for h. In our case here, length and width, those are just going to go over to the denominator, and we have height or thickness is equal to mass over density times length times width. Are there any questions on this problem here? And so notice how I wrote out what I was doing for each steps. If I asked you to do that on your test, I expect that. So make sure you guys are reading questions and your prompts very closely. For this one, I'll show even another step that I typically do, especially with three equations. They start to get complicated writing your steps. And so I always usually start with numbering them, equation 1, 2, and 3. And so already with three equations, that introduces even more ways to do it differently. Here's one way to do it. Would be first by step A, I'm going to solve for V in equation 3. Totally planned that rhyme there. So if we have density is equal to mass over volume, seen this a million times now, volume goes up to the top, density goes to the bottom, both on opposite sides. We get that volume is equal to mass over density. I now call this equation 4. This is a new equation. Step B. I set equations 1 and 4 equal to each other. So then I have length times width times height is equal to m over d. So now what I have to do is find the variables or variables that I can relate this new equation 5 to equation 2. That's our last step here, is to get those two together. And so if we look, A is equal to L times W. We have an L times W here. And so now we are going to solve for L times W in equation 5. If we do so, all we have to do is move this H to the denominator here. Then we get L times W is equal to M over D times H. Well, now we can just set that equal to equation 2, and we would get A is equal to M over D times H. Any questions?